Do you think you know where trees come from? Of course you do. You've seen it 1,000 times. You bury a seed in the ground, pour water, wait, and at some point something green breaks through the soil and starts growing toward the sky. Trees come from the ground. Everybody knows that. It's not even worth questioning. But it is, because here's something nobody, absolutely nobody, stops to think about. An adult oak weighs around 4,500 kilos. Some trees can weigh much more. That's tons of wood, bark, roots, and branches that didn't exist a century ago, and now they do. So here's the question. Where did all that mass come from? Not vaguely, not poetically, but physically. Where did those 4,500 kilos of solid matter come from? The obvious answer is the soil. The roots go deep, the tree pulls all of that up, and it becomes the tree. It makes sense, it seems obvious. So, let's test it. There is a famous experiment conducted by a Flemish scientist named Jean-Baptiste van Helmont in the 17th century. He took a willow branch weighing 2 kilograms and planted it in 90 kilograms of dry soil. He watered it for 5 years and let it grow. In the end, the tree weighed 76 kilograms. It had gained almost 74 kilograms of new mass. Then he dried the soil and weighed it again. The soil had lost less than 60 grams. 60 grams. 60 grams, the tree gained 74 kilograms, and the soil practically didn't change. So where did the other 73.5 kilograms come from? Not from the soil. That was the comfortable answer, and the numbers put an end to it. This is the moment when most people shrug and move on. They think there must be some technical explanation they don't understand, something about nutrients or chemistry. They file it away and forget about it. But stop, don't move on, because what happened is extraordinary. You just saw 74 kilos of solid matter appear out of nowhere, and you have no idea where it came from. That's not a small gap in your knowledge. It's a huge hole in your understanding of how the physical world works. And the answer, when you really see it, will change the way you think about trees, the air, and matter itself. Let me show you. All right, the soil doesn't explain it, but the water does, right? The tree drinks water all the time, liters and liters. A big oak tree absorbs about 380 liters of water on a hot day. Over a century, that's an absurd amount of water passing through the system. So, the mass must come from the water. That's the next obvious answer. And it even seems more satisfying than the soil, because you can visualize it. The roots drink, the water rises, the tree grows. Clean, simple, logical. But that doesn't work either. Here's why. Water is H2O, 2 atoms of hydrogen and 1 of oxygen. When the tree processes water, it breaks it down and uses the hydrogen. The oxygen is released back into the air, and that's exactly where the oxygen you're breathing right now comes from. But hydrogen is the lightest element there is. You would need an absurd amount of it to account for any significant mass. And besides, wood isn't made of hydrogen. Wood is made of carbon. Carbon is the backbone of every organic molecule, of every cell wall, of every fiber of every tree that has ever existed. Carbon is heavy, carbon is dense, and carbon makes up about 50% of the dry weight of any tree. The problem is this: the soil doesn't have enough carbon. Neither does water. The roots absorb minerals from the soil, nitrogen, phosphorus, potassium, and these elements matter for biological functioning. But all of them together account for maybe 1 to 2% of the tree's total dry mass. 1 to 2%. The vast majority of what a tree is made of can't be explained by anything that comes from the ground. The math just doesn't add up. No matter how many times you picture the roots drinking water, the numbers just refuse to cooperate. And then you're left with a problem that should really bother you. You have a 4,500 kg object in front of you. You know it grew from a seed that weighed just a few grams, and you can't explain the mass. Not from the soil, not from the water, not from anything you can see going into the ground. The answer is somewhere else, somewhere most people never think to look. And when you find out where, you'll see every tree you've ever seen in a completely different way. The mass comes from the air. That's it. That's the answer. Not the soil, not the water, not the minerals, not anything you can hold in your hand or see going into the ground. Almost all of the physical mass of a tree, the trunk, the bark, the roots, the branches, everything, comes from invisible gas floating in the atmosphere. Carbon dioxide, CO2, The same thing you exhale, the same gas that makes up 0.04% of the air around you right now. That's what trees are made of. A 4,500 kilogram oak tree is, in the most literal and physical sense of the word, solidified air. When Van Helmont did the experiment and couldn't figure out where the mass was coming from, the answer was floating right in front of his face the whole time. He just couldn't see it because it was invisible. See what's really happening. Trees absorb carbon dioxide from the atmosphere through tiny pores in their leaves called stomata. CO2 enters, and the tree breaks it down. It extracts the carbon from that molecule and uses it as raw material for building, chaining carbon atoms into long, complex molecules. And these molecules become everything: glucose, cellulose, lignin, the rigid fibers of the wood itself. The oxygen that's left after the carbon is extracted is released back into the air, and that's where the oxygen you breathe comes from again. The tree is essentially running a disassembly line for pure air. It takes invisible molecules, breaks them apart, keeps the carbon, gives back the oxygen, and that carbon becomes wood. Solid, dense, physical wood that you can touch, cut, and burn. This is not a metaphor. This is the actual molecular mechanism. Take a moment to consider what that means. Every wooden plank in every house ever built started as a gas. Every wooden table, every ship, every forest, every piece of paper you've ever touched was once invisible CO2 drifting in the atmosphere. Trees are machines that reach into the air and extract matter from it, stacking it in solid form, using nothing but sunlight as their energy source. Van Helmont was right to be confused. He just didn't think to weigh the air. And honestly, why would he? The idea that something solid comes from something invisible goes against every intuition you have about how matter works. But that's exactly what's happening. Every tree you've ever seen is crystallized atmosphere. Let that sink in. Then let me show you how. You learned the word photosynthesis in school. You probably remember something about sunlight, chlorophyll, and oxygen. You passed the test and moved on, but they never showed you what's really happening. And what's happening is one of the most extraordinary physical processes in the known universe. Let's go through this properly. Sunlight hits a leaf. That light isn't just heat or brightness, it's electromagnetic radiation. Oscillating electromagnetic fields traveling at 300 million meters per second. The same fundamental force that holds your atoms together. The same force behind magnets, electricity, and chemistry. When these electromagnetic waves hit a chlorophyll molecule inside a leaf cell, something remarkable happens. The energy from the light is absorbed by an electron in the chlorophyll molecule, launching that electron to a higher energy state. That energized electron then passes through a chain of molecules called the electron transport chain. And as it moves, it powers the production of ATP, which is the energy currency that cells use to do work. This is the light reaction. Energy captured from electromagnetic radiation and stored in chemical form. Now, the plant uses this stored energy to do something almost unbelievable. It takes the CO2, a completely stable molecule, which has no interest in being broken apart, and forces it to open up. It extracts the carbon and uses that carbon to build glucose, a simple sugar with the formula C6H12O6. 6 carbon atoms chained together with hydrogen and oxygen attached to them. This glucose is the first solid thing in this whole process. The first moment when invisible atmospheric gas turns into a real physical molecule that the tree can use. Then the tree takes this glucose and does something even more impressive. It chains thousands of glucose molecules into long repeating strands called cellulose, which is the main structural material in the walls of plant cells, and into lignin, which fills the spaces between the cells and gives wood its hardness and rigidity. Cellulose and lignin are what wood really is, and the chemical bonds that hold all these molecules together, the bonds between each carbon atom in every strand of cellulose, in every tree, in every forest on Earth. These bonds are electromagnetic. The same force, always the same force. Sunlight, electromagnetic radiation, hits a leaf. The energy is captured and used to forge electromagnetic chemical bonds between carbon atoms extracted from the air. These bonds build glucose. Glucose builds cellulose. Cellulose builds wood. Electromagnetic energy becomes solid matter. This is not a simplified version. That's what's happening. Now take that and go one step further, because it doesn't stop with trees. You eat food. That food is mostly plants or animals that ate plants, or animals that ate animals that ate plants. Every calorie you've ever consumed traces its origin to something that grew by pulling carbon from the air, which means that the carbon in your muscles, in your bones, in your brain, the carbon in every cell of your body right now, that carbon was atmospheric CO2 not that long ago. You are not made of earth. You are not made of water. You are made of reorganized air, stitched together by electromagnetic bonds and powered by sunlight. Every carbon atom in your body has a story. It floated in the atmosphere as CO2. A plant absorbed it, extracted it, and turned it into glucose. Something ate that plant. Something else ate that, and the carbon ended up in your food. Then in your body, forming the molecules that make you, physically you. And before it was in the atmosphere, that carbon was in some other organism that died and decomposed, releasing it back as CO2 to float freely until the next plant captured it. Carbon has been cycling through living beings and through the atmosphere for billions of years. You are a temporary arrangement of atoms that have already been part of countless other things before you, and they will be part of countless other things after you. This isn't philosophy, it's chemistry. Feynman used to say that a flower doesn't lose its beauty when you understand its biology. It gains something. Understanding what's really happening doesn't flatten the experience of looking at a tree. It deepens it. Because now when you look at an oak, you're not seeing earth that somehow rose up and created the bark. You're seeing hundreds of years of solidified sunlight. You're seeing electromagnetic energy captured from a star 150 million kilometers away, used to forge chemical bonds between atoms, carbon atoms taken from the air, stacked atom by atom into something you can climb, carve, and sit under. The tree doesn't draw from the earth. The tree draws from the sky, from the sun, from the air itself. And you, standing next to it, looking up, it's the same process. Different arrangements, same mechanism. Sunlight captured, carbon bound, matter built. You and the tree are performing the same fundamental trick, just in different directions.